Is there any way I can? Right, this is my effort to just go through a few questions. That possibility of popping them up in the GCSE paper tomorrow. So anyone want to join in, they can join. Drop the comments in here. If you want me to go through any particular topics, any particular questions, just drop here in the comments. Okay, thank you. So say work out the value of a when you've been given the equation that looks something like that, looks really scary. Okay, then what can you do? And it's 4 mark question. Get rid of the cube root, you need to cube both sides. Okay, so if I do that, if I cube both sides, I would get square root of 6 squared plus 8 squared, and I'm cubing that, and that will leave me with 125 a cubed. Okay, now I can possibly get, what's the 6 squared plus 8 squared, and then square root that. I possibly get a number for that. So, and that's 125 is also a cube number. So if I put that in the calculator, remember paper 3 is going to be a calculator paper. If I square that, 36 and 64, that's 100. Square root of 100 is 10. So we have 10 cubed, which is equal to 5 cubed times a cubed. If I want to work out what a is, I need to divide both sides by 5 cubed in a way. So I get 10 cubed divided by 5 cubed. And if I have cube on the denominator and the numerator, I can actually put it under one thing, 10 divided by 5 all cubed. Okay, and that will give me 2 all cubed. And on the other side, obviously I divided by 5 cubed as well, so I left with a cubed. Now 2 cubed is exactly the same as a cubed, so a has to be equal to 2. In other words, I cube root both sides. Okay, those cancelled with 5 cubed at the bottom. So a should be equal to 2. Again, like I said, anyone joining in, if you need any help or you need me to go through anything else, just drop it in the comment. Okay, I'm trying to go through until my battery lasts in here. Again, don't forget to make a comment if you want me to go through any particular questions. Right, okay. So there's a few more questions that's related to the power. Same base, a to the power 20 multiplied by a to the power 5. If you have the same base, then you add the power. So we should get a to the power 25. Same base, a to the power 20 divided by a to the power 5. We take away. So we get a to the power 20, take away 5, which is a to the power 15. And if you have a power, you multiply them. So we get a to the power 100 for this question here. Question 3. A shopkeeper compares the income from the sales of a laptop in March and April. Okay, by what fraction does the income from these sales decrease in April? So the price, and by what fraction does the income decrease in April? So we can say 1/5 more than the price is 1/5 more than the March, and then the number sold is 1/4 less than the March. So if let's say we're looking at the 100%, we want to have to work with the percentage here. Okay, so income from the sales last March and April. So whatever the 100% was, if price is increased by more 1/5 more than the March. Okay, so in April we will be charging 120% of the price. Okay, 1/5 is 20%, so we will be charging 120% of the price in March. But the number sold is 1/4 less than March. Okay, so that's the number sold is 75%. So the amount of the profit that you make basically is the 75% times 120%. Is anyone even watching this? Anyone watching it? No. Okay, fair enough. Anyway, so 75% and 120%. In the fraction world, basically that would be 710, and that would be 1210. So 710 times 1210. Okay, so no, not 710. Sorry, 75 over 100. 3/4. That would be 3/4. So we get 36 over 40, which is 9/10. So compared to the March, we're going to be selling 9/10 of the March product. The income would be 9/10 of the March. So you're losing 10% in terms of the sale, or 10% in terms of the income. You're losing 10% income. So that's what we're doing. Okay, 75% less customer and 120% price. So we're multiplying them together and you get 9/10, because you can multiply them easily using fractions or the decimals. It's up to you. If you did the decimal, 0.75 times 1.2 will give you 0.9. So you're making 0.9 of the what you made in March. Next question here, again slightly tricky equation to solve. Okay, so we got 2 to the power 3x over 2 to the power x minus 5, which should be equal to 2 to the power 17. Okay, so one thing is good, that is everything is in terms of 2 to the power something. So if I just multiply both sides by 2 to the power, or you can write it as saying a single 2 to the power, then you can actually do that as well. Okay, so let's say we multiply first 3 to the power 3x is equal to 2 to the power 17 times 2 to the power x minus 5, because you multiply both sides by that, so this one cancels out, you're left with that. Now if you have same base number and you're multiplying it, okay, then you add the power. Same base, you add the power. We just looked at it earlier example. Then that means I get 3x is equal to 17 add x minus 5. Okay. So now you go x is on both sides, so simple things, collect that 5 and negative 5 and 17, that gives you 12. And you take away x's from both sides, so that leaves you with 2x on that side, and you get rid of that x. So 2x is equal to 12. That gives you x is equal to 6, because you're dividing both sides by 2 and leaves you with x equal to 6. Any viewers? Yeah, we got one. It's a AQA, by the way. Okay, sorry. It's AQA. This is everything to do with AQA. But there is a massive difference in terms of what you're actually going to go through here. It's nothing different, okay? There are a couple of topics that Edexcel includes and AQA don't include those topics, okay? So there's 1 or 2 topics and you might have been done with it by now, okay? So there is a really, really tiny difference in all exam board. So if you revise for AQA or Excel, there is only small difference in terms of what they ask in which paper. Okay, that's about it. But there's not really big difference in terms of what exam board you're going to be looking at. Question 5. Lunch, choose one star and one main course. These are the common questions actually in the paper 3. That does appear quite often, these ones. Okay? And these are done on the exam pro. So these questions have been taken place somewhere in the past. Doesn't matter where, but somewhere in the past it has been done before. Okay, all we're doing is just looked at the topics and trying to print it through the exam pro. Okay, these are 4 starters, 10 main courses to choose from. Okay, so we have 4 starters and 10 main courses to choose from. 2 of the starter and 3 of the main courses are suitable for vegan. Okay, again, 2 and 3. So key information, you underline it so you don't forget, and read the question 2 times, 3 times if you need to, until you fully understand what the question is asking you to do. What percentage of the possible lunches have both courses suitable for vegan? Okay, what percentage? So first we work out how many possible combination there are. 4 starter and 10 main. Okay, so you have 4 choices for the starter, and for every single starter you have 10 choices for the main. So 4 times 10, there are 40 possible combination of the starter and main. Okay, for every starter you have 10 choices, so 4 times 10, 40 possible choices. And then 2 of those starters are vegan, so we have 2 choices for vegan starter, and we have 3 choices for the main starter. So 2 times 3, so 2 choices for the starter, 3 choices for the main. So there are 6 possible courses that you can serve to vegan. Okay, if you mix and match. So 6 out of 40 is a possibilities or percentage that you can use. 6 out of 40 courses that is suitable for vegetarian, and we just need to change 6 out of 40 as a percentage. So we're doing 6 divided by 40, which gives you 0.15, and multiply that by 100 will give you 15%. So 15% of the possible lunches have both courses suitable for vegan. Okay, so that's what we're looking at, 15%. Sketch the graph of y equal to x cubed. If you're looking to sketch the graph y equal to x cubed, generally any sketches is always going to be 1 mark. Some people remember what the shapes looks like, so you have straight line that way. Any straight line, those are going to be y equal to mx plus c. Then we have quadratics, y equal to ax plus c, and those are going to be parabola, either going upward positive or going down positive. Now we need to look at a positive x cubed, so which is going to be like this. That's it. That's a positive x cubed. Sketch the graph of x squared plus 3. So like we said, x squared would be going through the, that's y equal to x squared graph. Then you add 3 to every single value, so you're just pushing that 3 places up. Okay, so I'm going to be looking at this one here. So exactly the same, but instead of growing it through the 0, we're going to 1 over x, reciprocal. So okay, these ones are slightly tricky, reciprocal graph. So you can say, okay, when x is 1, y is 1. So it's 1, 1. That's the only point there. When x is negative 1, y is negative 1. So that's that point there. Sorry, I just looked at the comments. No, I don't have at the end of this session, or I'm going to try and do that Now, but then I continue the link. Y value would be half, 1/3, 1/4. So y value gets smaller and smaller and smaller if you make x bigger. The same thing if you make x really small. Let's say 1 divided by 0.1, it would be 10. So when you make it really small, it gets really, really big rapidly. So that's the parabola that you're going to get. And it's the same thing with the negative as well. Sorry, it's not perfect, but that's what I can say. That's the y equal to 1 over x graph looks like. Right, okay. The number of items n made in 1 hour by a machine is given by n equal to 60 divided by t. So t is the time in the minutes the machine takes to make one item. The value of t changes for the different type of item. On the grid below, for value of t equal to 1 to 4, draw the graph n equal to. So we can do this. T and n. So when t is 1, n would be 60. All you're doing is substituting t equal to 1 to 60 in here. Okay? So we're doing 60 divided by 1 gives you 60. When t is 2, 60 divided by 2 would be 30. When t is 3, 60 divided by 3, we get 20. And when t is 4, 60 divided by 4 is 15. So those are the 4 coordinates we got, and we can plot those on here. So 1 and 60. So starting from here, and then 2 and 30. And then 3 and 20, 4 and 15. So we know the graph will look something like this. Okay. So that's the graph reciprocal function again, like we said it before in the earlier question. And that's 2 marks. Use the graph to estimate the value of n. The machine takes 3 minutes and 30 seconds to make the item. So we're looking at this line. Always draw those lines in your paper. Use a ruler, draw the line. 3 minutes 30 seconds will start from there. So you draw a line up to the graph and then draw it across. Okay? So slightly above 15, let's say about 16. Okay, obviously we're estimating it. So from your graph, it will look like about 16 from my graph. So I'm not going to be doing it accurately. Otherwise, I could do that. 60 divided by 3.5. Okay, whatever the answer you get, that would be your answer. But in this case, 60 divided by 3.5 is not what we're looking for. We're looking to estimate using the graph and estimating it. So I'm going to have to write the value of n to be 16. So from my line, that's what it looks like. Okay, I know I plotted it slightly wrong, so that's right. Question number 8. So you get marks for drawing those lines. The only solution to x squared plus bx plus c is x plus 5. Work out the value of p. If there's only one solution, that means it's a repeated root. And those repeated roots, if x is equal to 5, that means you know the x minus 5 should be equal to 0. And that's the root that you're repeating. So you know it should be x minus 5 multiplied by x minus 5. And that would give you that quadratic expression. So if I multiply those out, you get x squared negative 5nx, negative 5x, that negative 5nx, negative 5x, so that we get negative 10x, and negative 5 times negative 5 gives you positive 25. That's the equation we get. Yeah, if you're making a noise, it does help. Can you take that outside and play outside? Please. Or you can take it inside the house. Sorry again. Right. Question number 9 there. Okay, the graph y equal to 4 minus x for values of x ranging from negative 2 to 5. From negative 2 to 5 is shown on the grid. Okay, so you're saying from negative 2 to 5 is given to you on that grid. Okay, and draw the graph of y equal to 2x minus 5. So we already got one, we need to do the other one. Okay, so remember, any straight line graph will have this equation, where c is the y-intercept, so where it crosses the y-axis. When x is 0, this is where x is equal to 0. So when x is 0, y is negative 5. So we know it's that point there, exactly halfway between negative 4 and negative 5. Okay, and then we got gradient is the number in front of the x, coefficient of x, which is 2. So when I move 1 across, I'm going 2 up. Okay, so when from there I'm going 1 across, 2 up, so it'll take me to negative 2. Okay. This point. Again, when I go 2 across, I would be going 4 up. So when I move 2 across, sorry, 1 across, I'm going 2 up. That's not right, is it? No. It's going to be always at one place, because this is going up in 2s. So from there, when I move 1 across, I'm going 2 up. This is halfway there. I move 1 across again, I'm moving 2 up. So it's always coming up to be a halfway line. 1 across, 2 up. At that point. So you can see where that line would be crossing each other. So I'm drawing the graph and making them equal to each other. So this is the point. Value is going to be 3, where both are equal to each other. You can solve the previous term. This is an interesting question here. It's your sequence. It's saying Fibonacci type sequence. After the first two terms, each term is sum of the two previous terms. So that P at 23 gives you Q. 23 at Q will give you 57. Q at 57 will give you R. So work out the value of those each individual letter. Okay? So we're going to have to work through simultaneous equation. So we're going to write it down saying, okay, P at 23, which is equal to Q. P at 23 is equal to Q. And then the Q add 50. Take away 23 from 57, it will give you Q. So Q is equal to 34. So now I know what Q is, I can work out what P is. So 34 take away 23 will give me P. So P is equal to 11. I substitute that in here. Okay, remember P at 23 gives you 34. So 23 at 11 gives you 34. Now once you know those values, you can work out what R is. So Q is 34. So we're doing 34 at 57, that gives you R. So R is equal to Q at 57. So we're doing 57 add 34, and it gives me R equal to 91. So those are the three values we get. But it starts from that, you can look at it basically. We know these two values, these two gives you 57. So this is the one we know everything. The rest we don't know everything. So we start with one that we know only one unknown and two values that we know. A and B are points on the curve. That's your A, that's your B. 2, 7 and 12, 0. Work out the instantaneous rate of change of y with respect to x. So what's happening in y with respect to x at point A? So we're trying to looking at the gradient of the line at that point. Okay, there is a multiple way of doing it, but in this case you generally draw a triangle, a straight line, and you're trying to make a triangle on that straight line, and use these numbers that way, and that will help you work it out. So when you're trying to draw that tangent, it's a straight line, that will get you 1 mark. So you're trying to draw that straight line, well, we always use the ruler, by the way. Okay. Again, look, I've done the 3 lines, none of those are actually good lines. I'm trying to get rid of all of this. I'm going to try to make the line now. It's not. What we're trying to do is work out the gradient of that line. Okay, that's a tangent to that point. So you're going to try and make a point where you can actually see what that's going to be. Okay, so okay, I'm going up, make a triangle in a way. So I'm going up 2, and I'm going from that 2.1 there, sorry, 1.2 to 2.8. Making saying that's 1.2 to 2.8, so that will give you 1.6. Okay, and that's the change there is 2, because you're going up from 2 to 6. So change in y divided by change in x. So rate of change would be 2 divided by 1.6. And that whatever the answer you get, that would be the gradient. Okay, rate of change with respect to x. Change in y with respect to x. So when you move 1.6 across, you're going 2 up. So 2 divided by 1.6 will give me 1.25. Now that would be different for every single one of you. But as long as you're showing that, you would get that 2 marks. Okay. The average rate of change of y with respect to x between A and B is worked out. Which statement is correct? Okay. Is it positive, is it 0, or is it negative? So if I go from A to B, it's negative, it's going downwards. Okay. When I move from A to B, so when I move from 2 to 12, 10 in the positive direction, I'm dropping 7 in the negative direction. Okay, so I'm doing negative 7 divided by 10, which is negative. The gradient, it is negative. So that's what we needed to say. Okay, and it's only 1 mark, so I don't think there is any reason to say anything else. Okay. I'm just checking if anyone's got any questions or anything that they want to say on here. Okay. Happy birthday, Rebecca. Right, okay. So question number 12. We got Chris visits library. He cycles to the library in a half an hour at the speed of 12 miles per hour. So these are speed, distance, time graphs. All of these that we looked in the last question as well. Speed, distance, time, or velocity time graphs. Okay. So the way it works, okay, if you know the distance and you know the time, okay, then when you work out the gradient, that would be the speed. Okay, the gradient of these lines would be the speed. So what's the gradient here? When you move 1 across, you're going 0 up. So that's It did not end. Sorry guys. Okay, it not ended. I don't know what went wrong. I have no idea what went wrong. Okay, sorry. So again, let's just look through that question 12. I don't know since when it went off. Okay. So traveling 12 miles per hour. So in half an hour, you travel 6 miles. Okay. 1 hour rest. Then it takes 45 minutes to travel 6 miles. So if you just use the formula, speed equal to distance divided by time, we do 6 divided by 0.75. 0.75 comes from changing minutes into hours. 1 hour is 60 minutes. So 60 to hours, we divide by 60. So we need to change that 45 minutes to 0.5 by doing 45 divided by 60 gives you 0.75, and that will give you that 8 miles per hour, the speed on the way back. It did not end. I don't know what happened. Okay, whatever. I don't know who I am is. Sorry, it's phone's getting heating up. It's really hot out here. Okay. In the diagram, DC is parallel to AB. So these two lines are parallel. Okay. So what we're looking to do here, show that the triangle ABD is isosceles. Okay. So A to B to D is isosceles. How do I show that? If I know these two angles are exactly the same, then I can show that these A to B to D is an isosceles triangle, or any of those two angles. So in this case, we need to show that these two angles are exactly the same. Okay, and if the two lines are parallel, okay, these two lines are parallel, then this angle here is same as this angle here. That angle is same as that one, because it's always alternate angle. Okay. We don't know about these two because these two lines are not parallel, so it can't be 52 that one. Okay. But what we know is saying, okay, let's say this angle here is x, that angle here is x as well, and that's the angle that we don't know. We're gonna have to keep it a y. So we now know majority of the angles in that parallelogram. Okay, or sorry, trapezium. So if these two lines are parallel, then these angles add up to 180. The 100 degree, 52 degree, and that x should add up to 180. Okay. Why? Because imagine having these two parallel lines. So this, when you drop it, and if you continue with that line, that 100 will drop here because it's corresponding angle. So that makes a straight line. So x, 52, and 100 adds up to 180 degrees. So let's say x in that case gives you 28 degrees. So that angle is 28 degrees. So this angle here is also 28 degrees. Now we know these angles add up to 180 degrees as well. So same thing again, parallel line. So that angle here, that missing angle, is 124 at 28, and then you take it away from 180. And I get that one to be 28 as well. Just happen to be 28. So then once you know that these two angles are exactly the same, therefore that length going to be exactly same as that length, makes this triangle here, A to B to D, this triangle, isosceles triangle. Again, you can show that information on the diagram and you still get full marks. If they're asking you to show something, if you don't write it on the diagrams, you need to give reasons why that is 128 degrees. So you can say these two angles, you have to write, label it, each one of those adds up to 180, therefore that's 28, and if that's 28, that one's 28, and if that's 28, these two add up to 180, so that turns out to be 28. So we now know these two angles are 28, therefore these two lines are the same, and therefore it's an isosceles triangle. enlarge triangle ABC by the scale factor negative 2/3 from the center 0, 2. This will probably be 3-mark question. Okay, in this case it turned out to be 2-mark. Well, it should be 3-mark question because we're doing 3 different things here. Okay, sorry, one thing, but we're using 3 pieces of information. Okay, we need to be enlarging it, so making it bigger by scale factor negative 2/3. So we're looking at the distances from the center. Okay, the center is 0, 2, so we mark that center 0 across and 2 up. So we're marking it at this point here. Okay. Now, whatever the distance that we need to go to each one of these points, we're gonna have to multiply by negative 2/3. Okay, so I'm going 3 up and 3 right. Sorry, from that point of view here, we're going 3 up and 3 left. So multiply 3 by 2/3, which was going to be 2. But it's negative 2/3, so man, 2 in the opposite direction. So I'm going to go 2 down and 2 right. So that point here becomes the C prime. So new C will go there. Okay. Then from C to A, again, let's remember 3 times 2/3 is 2. So C to A is 3 left. So I'm going to go 2 right. So that would be my A prime. And now from A to B, I'm going 1, 2, 3, 4, 5, 6, 6 down. So I'm going to go 4 up. Okay. 6 times 2/3 would be 4. So I'm going to go 4 up. 1, 2, 3, and 4 up. And that would be my B prime. Okay. So this is my image of that. So that's the enlarged shape. You can check that by joining C prime to C prime, B prime to B prime, A prime to A prime. They all will be going through the center. Okay? And that's my image there. Here's the circle and a sector of a circle. So that's the entire circle, that's the sector of a circle. I know it's not a minor sector, it's a major sector, the bigger sector. But it's still the same thing. Same circumference of the circle is same as perimeter of the circle. Work out the size of angle X. We don't know what the radiuses are, but we're going to use it in terms of R. So circumference of the circle, that's given to you in the formula sheet. So when you get your paper, you should also get the formula sheets. Area and the circumference of the circle is given to you. So it will give you in terms of 2 pi r and pi times diameter. Because we're looking for r, we're going to use this one, 2 times pi times r. So that's the circumference of this circle here. And the perimeter of that sector here is going to be 2 pi r. Okay, that's the entire circle. Then we're multiplying it by x over 360. That gives me this round part for the x degree. So that's the fraction of the entire circle I want. Whatever the angle is out of 360 degrees. Okay. And then we're adding 2 lots of r, because that gives you the perimeter of the entire sector, plus 2 lots of r. Okay. So now we're making those two equal to each other. So you can say 2r, everything divided by 2r. We can cancel those out. So divide by the left hand side by 2, divide right hand side by 2. So 2 cancels out. Divide left hand side by r, divide right hand side by r. Okay, that cancels out. So what it means is that doesn't mean you left with zeros. That means you left with 1 here. Okay. And then what you left with on the left hand side is this. Pi is equal to x times pi plus 1 over 360. Okay. Now you go pi on both sides of the equal sign in a way. So let's bring it onto the one side of the equal sign and get rid of the pi in a way, or just work with the pi as it is. So if I move that one here, pi minus pi x over 360 is equal to 1. So when I do that, I can factorize pi out in a way. Okay. Then I get 1 minus x over 360 equal to 1. Wait a second, what's majority of the part is right now. I'm looking for that one part that I'm missing here. Okay. Rather than doing this, what I could do actually is I'm gonna just do it on the side. Take that, move that one, and then deal with the pi and 360 afterward. Okay, so move that one, we get pi times x over 360. Okay, pi times x over 360. This part here, take away one from here, take away one from here, so you get pi minus 1. Then multiply both sides by 360. So you get pi x equal to 360 times pi minus 1. And then divide both sides by pi. So you get x equal to 360 degrees times pi minus 1 divided by pi. And that's what we get. You can look at it as in terms of 360 minus 1 over pi now, because pi and pi cancels out, so you can look at it so many different ways, but that's the value of x. 360 degree multiplied by pi minus 1 over pi. So I'm going to ignore this part. Okay? Also, I'm looking at what the value of pi. It's the other way of looking at it. Question 16. An isosceles triangle has base 16 centimeter and the perpendicular height 15 centimeter. Some of these triangles are used to make the large triangle. Okay? So you got 16, 16 and 16, 3 of those. And then 15, 15 and 15, so 45 is the height of that triangle. Work out the perimeter of the larger triangle. Okay, so we need to work out the hypotenuse here. Okay, so this triangle here, we don't know what that length is. We need to work out those hypotenuse. So let's split it into 2 halves. Imagine that was 16 altogether. Now we cut it into half, so that becomes 8. Height is still 15, so that middle part is still 15, and it's 90-degree angle if you cut the isosceles triangle. We're trying to work out what this hypotenuse is, this line that's saying. So what do? Pythagoras theorem. Square, add them and square root it. So we go 15 square, add 8 square. That will give you what? So you're using calculator, remember it's going to be third paper. 15 square plus 8 square. Give me 289. So square them and add them if you're looking for the biggest side, and then square root it. So square root, and I get 17. So that length there, x, is 17. So we know now the slanted height is 17. So it goes 17, 17, and 17. So 6 lots of 17 if you're looking for the perimeter. So I'm doing 17 times 6. 102, add 48. Which is 150, because that's 17, that's 17, that's 17. All of those lengths added together, okay, adds up to 150. So perimeter of that triangle would be 150 centimeters. But that is really important that you see what you're trying to do here. Okay, cut it into the halves. So instead of 16, now you have 8, and the height is 15. So you're looking for the biggest side there. Question 17. Vectors. All of those are vectors. So if you're saying work out A at B at C. So this is changing next, changing next, changing next. So you can add them together in a way. Okay. So we're now adding them up. 6 add -1 is 5. 5 add -4 is 1. So if I'm going 6 across, then 1 back, then 4 back, you only actually move 1 forward. That's what it means, adding them. And that bottom number is changing Y. So I'm first going 10 down, then 2 up, then 7 up. So altogether, all you're doing is actually going 1 down, which is -1. So when you add A, add B, add C, when you add all of them together, this is what you would get. So overall movement is 1 and -1. Show that the A plus 2C is KB, where K is an integer. Okay, obviously that's going to be the case anyway, but we need to be looking at that. You can factorize some number out when you do A add 2B. So A is 6 and -10. And I'm adding 2C, so I'm adding 2 times -4 and then 7. So now, okay, I wanted to be, when I add them, I should be able to factorize something, and that should be in that form. Okay, so let's say we got 2 times -4, so that's -8. Double the distance in the x direction, double the distance. You're making the vector 2 times bigger, double the distance in the y direction. So that's 14. Add 6 and -10. 6 forward, 8 back. That means you're just going 2 in the back negative direction. Okay, and then -10 and 14 up. So you're going 4 in the positive direction. Now if you look at it, look, double that B, you get -2 and 4. So we can actually write that in terms of B. So this is exactly same as 2 times -1 and 2. Okay, so K, value of K is 2, and we can get the B as the -1 and 2. So you can say it would be 2 times the vector B. If you're writing it down using letters, you always underline the vectors. That's the vector B, not just the letter B. They always write it using the bold letters. Okay, so all A, B, and C are in bold. You can see that. Okay, but when you're writing it down, you need to underline it to tell the examiner that you're writing vectors down. Again, if you have any questions, let me know. I can try and go through it. I'm checking every now and then. I'm recording through the phone, which is getting really hot right now. Okay, so if the stream stops, I will try and bring it back up as quickly as possible. Okay, so I'm going to try and do it as up to until the point where the battery in my phone runs out. Item made at factory have to pass 2 checks. 90% pass to the first check. The item that fails are scrapped. 99% of the items that pass the first check pass the second check. The item that fails are scrapped. Work out the diagram, complete the tree diagrams. Okay, so 0.9 passes, so obviously 0.1 fail. Sum of those branches at every point should add up to 1. Okay? And then if those that passes, again 99% of those passes again. So we're saying 0.9. So how many fails? 0.01. We completed it. That's it, done. In the second check. Because when they fail in the first pass, we don't have to check them again. They are scrapped straight away. The item chosen at random before the check. Work out the probability the item is scrapped. So it's scrapped that way. That's one way of scrapping it, 0.1%. Okay. If it fails, you scrap. That's it. And then or, and in other words, or it can also be scrapped if you pass first time and fail again. So we're looking at 0.9 multiplied by the failing of the, again, which is 0.01. Okay, so when you multiply that, that's another probability that you can describe. 0.9 times 0.01, which is 0.009. So these are the two possibilities that you can describe. So then if you're using the word or, you need to add them. So you can describe if it's 0.1% of the item, and it can also be scrapped if it passes and then fail, which is really low probability. So add that to 0.1 and we get our scrapping item probability 0.109. Okay, that's the probability that both item would be scrapped, and that item would be scrapped. The randomly chosen item would be scrapped. So 5 marks for that quick question. Sky graph, remember you have to say either positive correlation, negative correlation, or no correlation. And you also need to draw the line of best fit. The line of best fit needs to be as close as possible to all the points, not just the 1 point, not the 2 points. We want to keep the distance minimum as possible when you draw that line. Otherwise, you can have half of the point on the left, half of the point on the right. But look at the distances from each one of those points. It's going to be quite a lot when you do that. Okay, so we're going to keep it as minimum as possible. Okay, so what we doing in this question here? So sky graph shows the best high jump of the best long jump for 15 boys. So the long jump is vertical, high jump is the horizontal. So you can see there's a positive correlation. Someone who jumps high, they tend to be jumping long as well. Basically, long jump should be the bigger as well. Someone who couldn't do that, again, it tend to be. But there is an exception, small changes anyway. If I can jump long, doesn't mean I can jump high either as well. But on overall, someone who jumps long, they jump high as well. Okay, write down the type of correlation. Positive correlation. Someone who does the longer jumps, they do the higher jump as well. Okay, it's called positive correlation. And the word is correlation. Correlation. So both of those things are positively related. If you do well in one, you do well in other as well. Correlated, positively correlated. Liam has a best high jump of 166 centimeter. Use the line of best fit to estimate. So now you got 2 marks. So you have to draw the line of best fit. Again, I can't really use ruler on this right now. So I'm going to have to use pen and the rough guidance of what I'm going to be doing. But again, look at that. That's the line should be there, going through here. Keep the distance as minimum as possible. Every single one of you will have slightly different line. So it's fine. But you have to use that line of best fit to give estimate for 166 centimeters. So I'm going to try and draw the line from this point onwards, let's say here. And not perfect one, it should be straight line. But again, I'm sorry, I can't really do that over here. I'll try one more go. See if I can actually put something on here, a straight edge, and can draw that. Okay. Let's see, I can use the golf club. No, it doesn't work. It doesn't work, sorry. What about pool cue? Mic, like this mic. Okay, I'm going to try and draw that. I don't know. I'm going to leave. Okay, there we go. Just say you need to draw it using a straight line graph, okay? Just use a ruler to draw the straight line. Now we're saying we're estimating it for 166 centimeter high jump. So 166 at high jump would be one dot past that. So draw a straight line going through that all the way up to the point where you got your line of best fit, and then read it across and draw that line as well. So I got that line exactly halfway between the second point. So 532, 33. 533 would be the long jump for that person. Okay, 533 centimeters. There is always an allowance given to you on these ones, but you need to be showing these lines. As long as those are correct, you will get full 2 marks. Everyone will have slightly different line of best fit. So everyone's answer would be slightly different. Your answer will be judged on the basis of how you've done your line of best fit. And the last one, another boy has just best jump, high jump of 195 centimeter. So 195 centimeter, we haven't got any results for someone who's gone past 185. So there's a gap of 10 centimeters here. So there isn't enough data for us to actually predict something that's outside of the data we have. So it's going to be difficult for us to predict it. We can predict it, but it's not going to be accurate. Okay, and for that reason, that 195 is outside the range that we have available to us. Okay, so we can only predict it for the range that's within what we got. Question 20. Just going to try and see if I can actually get things in. Liam is trying to remember a 3-digit code. He knows the rule that the first digit is a cube number, the second digit is factor of 16, and the third digit is an odd number. Liam tries a random code that matches the rule. Work out the probability that this is a correct code. So let's look at how many possible options that we can get. If saying 3 digits codes, remember we got 3 digits code 1, 2, and 3. First number is a cube number. So cube number within first 10. So you got it's either 1 or 8. The first digit has to be either 1 or 8. So we have 2 choices to make that first digit. Okay. So we got 2 choices there. And then the second digit is factor of 16. So second digit has to be factor of 16. That's single digits. Okay. 1, 2, 4, and 8. There isn't any other factors of 16 within that single digit. So there are 4 choices for that. And then the third digit is an odd number. So third digit is an odd number, so you get 5 choices. 1, 3, 5, 7, and 9. So altogether, he could have possibility of having that many different number combination. 2 choices, 4 choices, and 5 choices. That it has to be done. Okay. So he could have used 1 and then all of those against it, and then 1, 1, and all of those against it. Okay, so those are the possible combination that he could have had. 2 times 4 times 5. Okay, so he could have had altogether 40 different combinations. And if he tries one of those combinations, work out the probability that this is the correct code. So one of those going to be correct code. Okay, so probability that he gets a correct code is 1 out of 40. Okay, so as long as he tries one of those, so probability that he gets it correct is 1 out of 40. So, again, any questions? Any shout outs? don't know who I am. Question number 21. A and B are positive values. Show that the 7a plus 2b plus 3b, minus 3b, always simplifies to the same value. Okay, let's collect the common terms anyway. Okay, so we write that by collecting the common terms. 7a and negative 3a will gives you 4a. If you're not sure what you're actually meant to be doing there, like I have no idea what I'm meant to be doing at this point right now by reading it first time. What I know is we're trying to simplify something because you're showing that you always simplify to the same values. Okay, so we're trying to simplify it. So simplify that top part. 7a minus 3a gives you 4a, so we get 4a plus 2b. Okay, and at the bottom 8a 2a gives you 10a, and then 6b minus b gives you 5b. So you can see that common thing here anyway. I can actually factorize out 2 from the top part, and it gives me 2 times 2a plus b. If you understand that factorization, just have a look at it, okay? 2 goes into 4, 2 goes into 2. So I can factorize that 2 out, so you can write here as a 2a plus b. And I can do the same thing at the bottom as well. I can factorize out 5 because 5 goes into 10 and 5. So I can write here as a 5 times 2a plus b. Because 5 times b will give you 5b and 5 times 2a gives you 10. So 2a plus b is in the brackets, 2a plus b in the brackets. So I can actually divide top and bottom by this entire bracket. So what you get as an answer is 2/5. So regardless of what the value of a and b is, you simplify your answer to 2/5 as always. The next one then, what we got is simplify that. So very similar, but this time it's a quadratic. The top part is the difference of 2 squares, okay? 4x squared minus 1. So we can write that down as 2 lots of x and 1. So square root of that, square root of that. One of them going to be positive brackets, one of them going to be negative. That's the difference of 2 squared for the top part. Now the bottom one you need to factorize it, okay? So I generally, when you're factorizing it and you have the coefficient of x squared, I always multiply them out. 5 times 4, so I've got 20. So I need 2 numbers multiplied to get you 20, and when you add them you get 12. I always start with that, okay? 2 numbers to multiply to get you 20, when you add them you get 12. So I get 10 and 2. So I know I need to be working with 10 and 2, okay? But again, they're going to be split into 2 parts as well. Okay, so I'm going to start going into the 23 area here, okay, but I'm going to be trying to show you exactly how it works, okay. So imagine you got this, where you got something x, something x here. When you multiply them, you get 4x squared. But I also need to get 10x and 2x here, okay. Because 10x and 2x will give you that 20 comes from 10 times 2. Okay. And this one here is 4x squared. I know that I need to get 4x squared. So 10x and 2x will give you that 12x. And then the last part is plus 5. So I know already now what my answer is going to be. How am I going to get 5 from these 2 numbers when you multiply them? So there's only one way you can get 5 is when you have 5 and 1. Or you can have 5 here and 1 there. But I need 10x as well. So I can do 2x plus 1. Okay, that gives you 5x times, so 2x times 5 is 10x. And if I have 4x squared here, I know I need to have 2x there as well. So I'm doing 2x plus 5. So 2x times 1 is 2x. 2x times 2x is 4x squared. And 2x times 5 is 10x. So this is what we get there. So I got my 2 answers, 2 brackets here. 2x plus 1 and 2x plus 5. I do that a lot quicker when I'm not explaining it, okay? Because I've done those questions so many times, I don't have to worry about it doing it in slow motion, okay? So I'm going to try and get rid of these again, so I can do the next question on here. So more questions you do using this grid method, the better you get at it. And it's better in terms of the understanding as well. You always understand it and you can work through that. I'm sorry. Again, if you have any comments, please let me know. If I'm making any mistakes, please let me know as well, okay? I will upload these documents soon, as soon as my battery is about to die. So as soon as it dies, I will upload this document so you can look through it. So 2x plus 1 and 2x plus 1, you can cancel them off. Just divide top and bottom by that. So your simplified version is this. I have 2x minus 1 over 2x plus 5. Okay, that's my answer for that one. Solve this equation. Again, very similar things, okay? Algebraic expressions does look really tricky, but it's not, okay? You multiply them together, lowest common multiple. So when you're adding fraction, you have to have lowest common multiple. So that would be my lowest common multiple, okay? So my bottom number for both of those fractions would be x plus 4 multiplied with x minus 2. That's the lowest common multiple of both of these fractions. Then I need to multiply x plus 4 by x minus 2, so I multiply that x by x minus 2 as well. So at the top I would have x times x minus 2. Then I'm adding, multiplying x minus 2 by x plus 4, so I need to multiply that 7 by x minus 2. Sorry, x plus 4. So remember, both of those fractions are over x plus 4 times x minus 2. So you can write the entire thing separately, but I'm trying to save space so we can move on to question 24 quickly. Okay. Now I need to multiply these out and you get some sort of expression. So you get x squared minus 2x plus 7x plus 28. That gives you 5x plus 28 over this. X plus 4 and x minus 2. So now remember, you need to factorize top one, x squared plus 5x plus 28. Okay, so two numbers multiply to get you 28, but when you add them you get 5. Okay, so I get 7, no, two numbers multiply to get you 28. So I'll look for the factors 1 and 28. Okay, just forget that. Okay, we still need to make that equal to 1. We're not solving it yet. Okay, so we need to make that equal to 1. So that's the left hand side. I'm going to make that left hand side equal to 1. So now I need to get rid of the numbers from the bottom, so I multiply those out. So I get x squared plus 5x plus 28 is equal to these two brackets multiplied on the other side. So we get x squared plus 2x minus 8. Now we can take away x squared from both sides. That gives you rid of that. Take away x squared from both sides. Take away 2x from both sides. So it gives you 0 there, but it leaves you with 3x on this side. And then you take away 28 from both sides. So take away 28 from here, take away 28 from here. We get 8 and 28 will give you 36 negative. So 3x is negative 36. That gives me x equal to negative 12. Because divide both sides by 3 and you get x equal to negative 12. Okay. I was in the zone where I'm thinking about simplifying these. Okay, but we forgot that it's a solving equation. That left hand side is equal to 1. So this is left hand side, that's the left hand side, and we're making it equal to 1. So when I'm making it equal to 1, I can multiply these two with the 1. So that's just multiplying these two brackets together, which gives you there. Expand and simplify, triple brackets, okay? Really, really easy 3 marks there. You can look at it. Okay, Wolfie, let me finish that question, then I'll go through the Pythagoras in 1 minute, okay? multiplying these two brackets. So you can use a grid method to multiply those brackets. Again, 2x plus 5, 2x minus 5. 2x times 2x gives you 4x squared. Okay. 2x times 5 gives you 10x. 2x times negative 5 gives you negative 10x. So these two cancels out. And minus 5 plus 5 gives you negative 25. So when you multiply those two brackets, we get this. 4x squared minus 25. And then multiplying this with the 3x plus 7. So again, we can do the same thing. Exactly the same thing that we just done here. Use a grid method. We got 4x squared this time minus 25. And then you got 3x plus 7. 4x times 3x, 4x squared times 3x gives you 12x cubed. 3x times 25 gives you minus 75x. 28x squared. And 175, but negative. So that's your answer. 12x cubed, 28x squared minus 75x minus 175 when you multiply them out. Yes, question 26 is next. Okay, I'm going through the next question. Okay. Thank you. Right. So, someone said the Pythagoras. Okay, Pythagoras only applies if you have a right angle triangle. Okay. And in the right angle triangle, the biggest side is opposite of the biggest angle. In the right angle triangle, 90-degree angle there. That means this 90-degree has to be the biggest angle. Okay. If any other angle is 90-degree, then it goes more than 180 degrees. So that's your hypotenuse. And if you're looking for the longest side, 3 steps. Square the smaller sides. Okay, let's say that's 3, that's 4. Square 3, square 4, and add them if you're looking for the biggest side. So square them, add them, and then square root it. That's done. Okay, so when you get 9 and 16, add them, so you get 25. And then square root of 25 will give you 5. So that longest side there is 5. If you know the longest side and looking for one of the smaller side, you do the same thing. Let's say we knew that was 5. Square them, so it's 25, 16. So that's squaring them. And then if you're looking for the smaller side, you take away. So 25, take away 16, that gives me 9, and then square root it. So square them, take away, and square root it. That's if you're looking for the smaller side. That's how Pythagoras works. Okay, square it is add if you're looking for the longest side, and it's subtract if you're looking for the smaller side. And then at the end, make sure you square root it. And if you have calculator, that's really straightforward things to do. Right, question number 25. I need to prove that this is a square number. Proving questions tend to be really, really difficult. Okay, let's see if I can actually get rid of this any better way. I'm going to delete all of that. Okay, so the top part will disappear as well. Sorry, that's the quickest way I could delete that. Right, x is an integer. Integer means a whole number. If I'm looking to simplify something and then say that this is going to be a square number, so I need to be able to write the same thing multiplied by the same thing. As long as I can do that, then I can prove that this is going to be a square number. Okay, so let's say trying to simplify things first. Okay, expand the brackets, expand that, and see if we can find the difference of two squares, or looking at any square things in there. Okay, so we got 35 plus, if I multiply these brackets out, let me just write at the top so I get a little bit more space here. Okay, so 35, expand the bracket, so that would give me 9x squared. 1 times 3 is 3, so plus 6x. 1 times 1 squared gives me 1, so that's coming from there. Okay, so I got 35 plus this minus, So this is negative 2x. Remember, sign in front of the number or letter is with it. So negative 2 times 4x gives you negative 8x squared. And negative 2x times negative 3 gives you positive 2. Negative multiplied together gives you positive. So that's positive 6x. Now you can collect the common term, so you can actually see that what you got is one quadratic thing. So we get 9x squared, take away 8x squared. So we just got x squared. You always write the terms with the highest order, means the highest power first. So we got the x squared first. So we're dealing with x squares here. Okay? And then we're looking at the x's. So I got the positive 6x and positive 6x again. So we got 12x. And then we got the numbers 35 and 6. That's also a square number, so that's a good news. If I factorize that, it factorizes to x plus 6 and x plus 6. If I have a number multiplied by itself, it's going to be a square number. Again, if you're not sure how to factorize it, you can use the grid method. Okay, I got x squared, so that we know is going to be x and x here. And then that gives you the x squared. Also, the number by itself is 36. Okay, so two numbers multiply together to give you 36. So that number times multiplied by that number gives you 36. But that number times x, so these are the x terms come from here, 12. So when you add those two numbers, that gives you 12. So we look for factors of 36, that adds up to 12. So 1 and 36, no, doesn't give you 12. 2 and 18, no. 3 and 12, no. 4 and 9, 13. So it's close, but no. 6 and 6. So those are the two numbers that we were looking for. Positive 6, so 6x here, and positive 6, so 6x here. And now 6 times 6 gives you 36. So those are the two values, x plus 6 and x plus 6 that way. Alright, here's your question 26. Who wanted to see me doing question 26? So question 26 here, you got f of x is half x. And g of x is equal to x minus x squared. I was actually helping someone with that question in the after school revision session of the day. Solve inverse f of x equal to g of f of x. Okay, so these are just saying function of x gives you half times x. So whatever you replace it with that x with, you need to replace that x with as well. So if I'm looking for the inverse function, then you need to write it in terms of the y. So instead of function of x, we're saying let's give it a letter, y. Y equal to half x. And if I'm looking for the inverse function, means input becomes my output. Okay, that's what I'm looking for. So making x the subject. So if I'm making x the subject, multiply both sides by 2, you get x equal to 2y. So now that's my input became the subject, so inverse function. Okay, so inverse function then f of negative 1x is same as 2x. Okay? So replacing x with y, because when you're writing a function of x, everything has to be in function of x. So that's inverse function of x is just 2x. And we need to be doing that g of f of x. So whatever the x is, we need to put that function of x inside that. Okay? So in here, wherever the x is, I'm replacing x with function of x. And what is the function of x? Half x. So I'm replacing it with half x. So instead of g of x, now we're going to have g of half of x. So wherever you see the x, you need to write it as a half x. So that x becomes half x, and that x squared becomes half x whole squared. So I can simplify it better. So half x is same as x over 2 minus half of x squared gives you x squared over 4. Now if I'm solving these two equations, inverse function with this. So 2x is equal to half x minus x squared over 4. I'm solving that equation. So I'm going to write it down. 2x is equal to x over 2 minus x squared over 4. If I want to get rid of the fractions, I'm going to multiply entire things by 4. So if you multiply left hand side by 4, we get 8x. If I multiply this by 4, I get 2x. Because 4 divided by 2 is 2, so that's left with 2x. And if I multiply that by 4, I get negative x squared. So there's no fraction now. Okay, you got x squared on both sides. Sorry, x is on both sides, so you can get rid of that by, let's just say, adding x squared on both sides. Okay, so you get x squared plus 8x equal to 2x. Then I take away 2x from both sides, we get x squared plus 6x equal to 0. And then what you do is saying, okay, factorize x out. So you get x plus 6 equal to 0. So you get two answers. X has to be equal to 0 or x has to be equal to negative 6. So those are the two answers that we get from solving these two functions. Right, let's see if any comments there. Not really. Right, cos x is equal to cos 60. Work out the value of x when x is between 90 and 360. So cos 60, let's look at cos 60. Where is the cos 60? This is a graph of cos x. So cos 60, 30, 60, 90. So this is where cos 60 is. So we're looking at cos 60 goes there. And then you read the line across there. Okay? So cos 60 value there going to be half. Okay? But also another value between 90 and 360. 90 and 360. Another value, if you continue with that line, it's going to give you the same value here, which is 270 plus 30 gives you 300. So x is equal to 300 between 90 and 360. So cos 300 is exactly the same as cos 60. So that's 60 and that's the value of 300. Will give you exactly the same value on both sides. Cos x is equal to negative cos 60. So negative cos 60 would be there, same thing. Negative of cos 60. Something is equal to negative of cos 60. So whatever the value we get negative of that. So that's half. Okay? And we want the value between 180 and 360. So that's negative cos 60. That's half there. So negative cos 60 would be negative half. Okay? So 60 will give you that, and then you might make it negative. And between 180 and 360 would be 30 less than 270. So that would x value would be 240. That will give you the same thing here. Okay, there. It also gives you 120, but we only want between 180 and 360, which is that value there. Okay. Question number 28. We got the graph of speed and the time. If you know the time and the speed, then they generally ask you to work out the distances at some point, and that would be the area underneath that graph will cover the distance. So that you always work out the area underneath the graph. That gives you the distance if you know the speed and the time. Okay. How many seconds had the horse run? Distance of 75 meter in. Okay, so we already know the area 75 meters squared. So let's just work out the area of that triangle. That will help us work out the area of everything else afterward. So the area of that triangle, where base is 4, height is 10. So it's 4 times 10 times half will give me 20. So I need 75 meters of the distance. That's 20 meters already here. So I'm doing 75, take away 20. That means I need still 55 meters square of the area. Okay, so that's 20 meters distance in a way. So sorry, I need 55 meters. So now we can look at it saying, okay, height is 10. 10 times what gives me 55? That's what we're looking at. Okay, because this is now a rectangle. 10 times 5.5 will give me 55. Okay. So I need to go 5.5 more than this. 4 at 5 is 9. So 9.5 here. Okay. So that gives me the area of 75 meters. Okay, square. Okay, so this is the 75 meter. That's the distance up to that point. So it'll take the hose 9.5 seconds to cover the distance of 75 meters. Okay, so it would be 9.5 meters. Sorry, 9.5 seconds. It takes hose 9.5 seconds to cover the distance of 75 meters. Right, I'm going to try and attach this file to this stream. I think there's not many people watching, so I'm just going to end it now. Okay, and then good luck with the exam. I'm going to try and come back possible after my dinner. Okay, there are a few more questions to go, so I'm going to try and come back to this and try and go through as many questions as possible in a few minutes. Okay, thank you for watching, and I need to charge the phone as well. It's nearly dying now. Okay. So thank you. How do I end it?